Oops. So example 3. Okay, let me read this. This is an application problem. All right. It says, suppose that 200 million so 200 million is spent annually by tourists in a certain state. Further, suppose that 75% of the money is respent in the state and then respent over and over again. Each time at a rate of 75%. So it says further suppose, so you have 200 million that is spent annually by tourists in a certain state. Further, suppose that 75% of that money is respent in the state and then respent over and over again each time at a rate of 75%. So every year, let's say this is happening. Determine the theoretical total amount spent from the initial 200 million if the money can be respent an infinite number of times. Oh no, so okay, so they're assuming just one annual, so they take 200 million and you're spending 75% of it, or you're respending 75% of it over and over and over again. That's what they're doing. Yeah. So let's represent that as a problem. So here we go. So what that means is we start with 200 million, right? And then what happens? They respend 75% of that. So 75% of 100 is 150. Right, and then 75% of 150 is 112.5, and so on. Okay, so what we end up with is this infinite series here, and we want to know what does this infinite series theoretically add up to if this is a real life case. So now in this case here, it is a geometric series. Why? Because we're taking 75% of each term. So the common ratio is what? 3/4, right? So in this case here, A1 equals 200 and R equals 3/4. So the absolute value of R is less than 1, which means that this series is convergent. And we can use our formula to find it. So S1 equals A sub 1 over 1 minus R. And so now A sub 1 is 200. So we take 200 divided by 1 minus 3/4, which is going to be 200 divided by 1/4, which equals what? That's going to be 200 times 4. So now, that means what? The total amount of money spent is 800 million, right? So these are in the millions. All right, that's it.